Okay, so for these notes, we're going to start with integration by substitution. This is something that you learned in SL. So it should just be a review. But basically what I do is I look for the most complicated thing, and then it should have something along with a that we're going to turn into a U. So the complicated thing has another function attached to it. So to me, the complicated piece right here is this. So I'm going to redefine this. And so we're going to have the integral of 3 times 6x minus 1 times e to the u du. But now that means that I've defined u to be 3x squared minus x. And so the next step is to figure out what du dx is, which would be 6x minus 1. And then lastly, we're going to solve this equation for dx. Sorry. We're solving this equation for dx so that we can replace it and get this in terms of du. So that would be dx is equal to du divided by 6x minus 1. So now when I rewrite this, I have the integral of 3 times 6x minus 1 times e to the u du divided by 6x minus 1. You'll notice that we have two 6x minus 1s. So now we can cancel those out. And whenever we have a constant, we can pull it out. So now this is 3 times the integral of e to the u du. And I know that the integral of e to the u is e to the u. So now I have 3 e to the u plus c. And then lastly, we're going to plug back in our u. So we have 3e to the 3x squared minus x plus c. Now, all of that should be something you've seen before, so I'm not going to spend too much more time on that. We're going to go ahead and move on to integration by parts. Integration by parts is basically very similar to product rule. So it's two functions being multiplied together, and then we're going to rewrite it so that we can use this. The hardest part, in my opinion, of integration by parts is choosing the correct u term. So really we want to choose a u that gets simpler when you differentiate it, meaning you take the derivative, it gets nicer, and a v that doesn't get any more complicated when you integrate it. Something to help you remember your u term is this I late. So that I late section stands for inverse trig functions, logs, algebraic functions, trig functions, exponential. Whichever one of these you see first is in this list, whichever one you see first, that should become your u. So let's go through a couple of these examples. Okay, so the first one we have is x e to the x. Now from my I late, there's no inverse trig function, no logs, but there is an algebraic function, and that is just the x. So that tells me that my x is my u term. So here I have u is equal to x, and I'm going to go ahead and define du dx, which is just the derivative, which we know the derivative of x is 1. And that means that my e to the x is my dv dx. And I'm getting that from the formula where it says u, the integral of u dv dx. So that means that this has to be dv dx. And so to figure out what v is, I would integrate this. The integral of e to the x is just e to the x. So now I have all of the pieces I need to use my equation. It says that it's equal to uv, so that would be x e to the x, minus the integral of v du. So the integral of v is e to the x. That's my v term, and then my du dx is just 1. So it should look like that. And then when we integrate this, we get x e to the x minus e to the x plus c. And just to make this a little bit prettier, I see that there's an e to the x in both of them. So I'm going to pull that out. So I have x minus 1 plus c. So that's the first one. And then let me do the next one as well. So the first thing I see, I don't have an inverse trig function, but I do have a log. It's a natural log. So that's going to become my u term. So I have u equals the natural log of x. And then that means that du dx, my derivative of that, is 1 over x. And then my v term would be the other piece. So dv dx is x. And in order to figure out what v is, I have to integrate it. So the integral of x is x squared over 2. So now using all of this information, I just have to plug it into my formula. The first one is just uv. So that would be the natural log of x times x squared over 2 minus the integral of x squared over 2 times 1 over x dx. And I can simplify that. This would become minus the integral of x over 2 dx. And that simplifies. So once we take the integral, we're left with, I'm just going to write this a little bit prettier. I'm going to put the x squared first, natural log of x. And then when we integrate this, this becomes x squared over 4 plus c. Pretty straightforward. Again, you can then take the derivative of all of these pieces to make sure that you get the right answer. But because there are two things being multiplied, it's product rule. So this is the inverse of product rule. Okay, so there are a couple times, like in the next example, where you have to do repeated integration by parts. And I'm going to go ahead and say that unfortunately, I think the textbook has a mistake. So the question says, show that the integral of x squared cosine x dx from 0 to pi over 2 is equal to 1/4 times the quantity of pi squared minus 8. I don't think that that answer is correct because when I followed their work in the textbook, they had a mistake. So I'm actually going to do it the way that I think it's supposed to be. And I will cross out the end. So instead of it saying that it's equal to this, we're going to try to show what I think it's equal to. And y'all can follow along. And if you catch my mistake, even better. But I think I went through it a couple times and couldn't find. Yeah. So the first step is to define my u and my v. So I'm reading through. I don't have an inverse trig function. I don't have a log, but I do have an algebraic function. It's x squared. So that means that my u is equal to x squared, which means that du dx is 2x. And that means that dv dx is the other part of my equation, which was cosine x. If I integrate that, I know that my v is sine of x. Okay, now all that ugly mess comes to show that I have now u times v, which is x squared sine of x, minus the integral, and this would be 2x times cosine of x. But you'll notice that we're running into the same problem. So this is from, 0 to pi over 2. When we have these pieces, this one, this second term is another integration by parts. It means I have to do it again. So this time, my u is going to be 2x, which means my du dx is then 2. And my dv dx by default is cosine of x. Sorry, that should say sine of x. So then this one would be sine of x over here. And that means that my v is then, if I were to integrate sine of x, I end up getting negative cosine of x. Okay, so with all of this information, I now get to turn this red box into a new integration by parts. So just this red box part is equal to negative 2 cosine of x, negative 2x cosine of x, because it's the u times the v, minus the integral of v times du dx, which is 2. Now that one is just a plain integral that we can solve, and these are all from 0 to pi over 2. So then just this red box is equal to negative 2x cosine x from 0 to pi over 2. And then the integral of negative 2 cosine x is negative 2 sine x from 0 to pi over 2. Okay, but then the problem comes in, oh, and it's minus a negative, so that becomes a plus. The problem comes in when I combine all of these things, because this is just my red box, but there was a negative in this blue equation. So this negative is distributed now to all of these things. So now I'm left with x squared sine of x from 0 to pi over 2. And then that minus cancels out. So we have minus a negative, which is plus 2x cosine x from 0 to pi over 2. And then minus that plus 2 sine of x from 0 to pi over 2. And then all we have to do is plug in our values. So here I would have pi squared over 4 times sine of pi over 2. From your unit circle, you should know that that's 1. Minus 0, that's just this first term. Plus, and then when I plug this in, I get pi times cosine of pi over 2, which cosine of pi over 2 is 0. So pi times 0, minus 0 times pi over cosine of 0, which is 1. And then minus 2. So sine of pi over 2 is 1. So I have 1 here. Minus 2 times 1. Minus a negative. Sine of 0 is 0. All of this comes out just mostly to zeros. So this whole term goes away because it's just 0 times 0. This term goes away because it's 0. This term goes away because it's 0. So we're just left with pi squared over 4 minus 2. So that is not what they got in their answer. And that's because they forgot to distribute their negative right here. but I did. Okay, lastly, we have reverse chain rule, which can also be called integration by inspection. This one's very similar to the first one that I did. This is a really ugly formula. I personally don't think it helps that much. If it helps you, that's fine. It just confuses me. I basically do this as reverse chain rule. Remember, chain rule was derivatives when we were working from the outside in, or from the inside out. So we're basically working the opposite way. So for me, the innermost function that I see is this. So I have 3x plus 5, and it's being raised to the third power. Now, if I wanted to go, remember, integrals go up 1 power. So if I wanted to go up 1 power, it would be that quantity to the 4th power. So I have 3x plus 5 to the 4th. Now let's double check it by taking the derivative. And we have a plus c at the end because there's no numbers. So when I take the derivative of this, I take the derivative of the outside. So it would be 4 times 3x plus 5 raised to the 3rd power times the derivative of this inside term. So the derivative of that is 3. And that's how they got 12 on the outside, because of this 3 times 4. Okay, let's look at another one. This one has sine pi over 2 times x. So for me, I'm going to go ahead and start by figuring out, what do I take the derivative of to give me sine? And so the thing I take derivative of would be negative cosine. When I take the derivative of that, it would give me sine. So I'm going to try negative cosine pi x over 2. So let's go ahead and see what happens when I take the derivative of this. I get sine of pi over 2 x. But I also have to multiply times the derivative of the inside, which would be pi over 2 plus c. Now, that has an extra pi over 2 than this equation, so I need to get rid of it. How do I get rid of a fraction? That's right, I multiply by the reciprocal. So instead, I'm going to add the reciprocal to the front of this function, which would be negative 2 over pi. So if I have this function here, now when I add the negative 2 over pi, it's going to cancel this out so that I end up with my first equation. So the last example that I have, it follows the same pattern. This time, this would be your other function. For me, I think this one helps when I use e to the u substitution. I'd like you to try it on your own. It should be your final answer, 1/2 e to the x squared plus 3 plus c. You have Delta Math and on Google Classroom, there are more IB style questions, so go ahead and do all of those.